As the question says, a train starts from rest and moves with a constant acceleration of 2 meters per second square for half a minute. The brakes are then applied and the train comes to rest in 1 minute. Find the total distance moved by the train, the maximum speed attained by the train, and see the position of the train at half the maximum speed. So let us first draw the graph for this question, that is a VT plot, marking it as 1 and 2 seconds on the time axis. We know that till half second it is having an acceleration of 2 meters per second square. So here is a straight line. Till half we are having the velocity as 1 over here, and in next 1 minute it comes to rest. So at somewhere here it comes to rest. Moving back to the question, we need to find the total distance d, which can be found out by calculating the area of this VT curve, that is this triangle, which is obviously very easy. As it is the area of the triangle, it is half into base into height. Base is 3 by 2 and height is 1, coming out to be 3 by 4, that is 0.75 meters or 75 centimeters. Similarly, moving on to the second part of the question, the maximum speed attained by the train. It is very easy to look from the graph that the curve is never ever crossing the y coordinate 1. So obviously Vmax is 1 meter per second. Now the C part of the question, in which we have to find the position of the train at half the maximum speed. Now the maximum speed is 1, so the half will be half. So there will be 2 instances where the train will be having the velocity equals to half of the maximum speed. Marking these points as A and B respectively, and let us work to find the coordinates of point A, that is the position of A. For A, we can write as u is equals to 0 because the train started from rest over here. Coming back, we have the acceleration of 2. We have time t equals to somewhere in between 0 to half. Final velocity, we have half of the maximum, that is half meter per second. So simply we can employ the third equation of motion to write as 2as equals to v square minus u square. So twice of acceleration, that is 2, into displacement equals to 1 by 4 minus 0, that is s equals to 1 by 16 meters. Let us find the other point B, for which we can write as u is equals to 1 meter per second, v equals to half, acceleration equals to minus times 1 over 1, that is minus 1. So again, employing the third equation of motion, we have 2 into minus 1 s equals to 1 by 4 minus 1, that is minus 3 by 4. Cancelling the minus sign over here, getting s equals to 3 over 8. So we have found out the 2 points at which the train will be having the speed half of its maximum speed. Now just note that in all such type of questions, just prefer to make a graph, just a rough sketch of it, so as to get the idea what we need to do in the question.